Yeah, I do it Spanish.
All right.
For all of the audience.
Okay, no.
So why don't we have everybody introduce themselves? But first, let me just tell everybody, this is Martin Espinoza with the PressDemocrat, and I'm here live up on Fountaingrove. What's the street here?
Palazzo Court.
Palazzo Court. And what part of Fountaingrove are we in right now?
Yeah, the Sienna or
Okay.
Fountaingrove 2.
Yeah.
And I'm here with John and Delia, is it? Magarva? And you guys are building a concrete home.
Yes.
Why is that?
Well, multiple reasons. My career has been largely in building concrete structures for the last 30 plus years. And I've always been intrigued by, even before I started in concrete, I was intrigued by concrete as a medium for building the best medium if you could figure out how to make it efficient from a construction standpoint in having a concrete residence. So all these years later, you know, we lived here, our house burned down, went to the home show with our friends, ran into the IntegraSpec booth, and started talking to Nick, who has a lot of experience building concrete houses and has been in the industry a long time, all the way through, long before they had the diaphragm systems of the roof and the floors in concrete as well. And so when I found out that they now had those components, to me the whole thing made sense logically, and so caused me to have a pretty long, deep conversation with him on that day. And I was pretty much sold since then. So
what are some of the advantages of a concrete house?
Well, let's start with investment. These homes are already meeting the 2020 code for net zero and have for a long time. Wood frame homes will have to meet that for anything built after 2020, which is going to be increase their costs significantly, where these homes are already meeting 2020. From an investment standpoint, if you could go buy one or the other 10 years from now, those homes will not be net zero. These homes will be net zero. The new wood frames home will be net zero at a higher cost. So from an investment standpoint, it makes sense long term. So that's numbers, dollars first. Second is fire. We're now in a wildland interface, as we all know. And you know, I don't want my house to burn down again. So this house is all concrete from top to bottom. It's going to have light gauge metal framing inside. There won't be a piece of wood in the structure. And our floors are all going to be tile. So glass tempered walls on the outside, no way for fire to get in. There are no vented eaves and there's no vented floor space. So, and nothing to burn anyway. So that's fire. Seismically, Rogers Creek Fault is right over here on this ridge, running north and south. We're maybe a half a mile away from the Rogers Creek Fault. We had earthquake insurance on our old house. Thought that would probably happen before they burned down. Not that we didn't have fire insurance, but so we had earthquake insurance. These are, Nick has been telling me that these meet the seismic zone 10 for structures in that seismic zone. We're 7, which is bad enough here. So I do not believe, regardless of whether that fault pops or not, I'm not worried now that this house is not going to be here in any event, whether it be from an earthquake or from a fire. So those are two huge advantages. Go to the thermal and energy advantages. Yeah, the energy advantages in general. It's already net zero, which speaks to that, as well as the whole Title 24, the LEED green movement. This already meets those requirements or those regulations or those goals. Is what they are today. So you know, it's quieter, it's cooler or warmer, easy to heat, fun to build.
Okay.
I mean, we're having a good time building
Legos.
Like big Legos. So I've got somebody asking me, what does it look like? They can't see it right now. So
right
give
now,
us, where are we?
So we're at what we call a walkout cellar. We'll have a living space down here, wine cellar, big storage area, open terrace, have a kitchen, a bathroom, fireplace, TV. That's in this area. And then the stairs will go up to the main floor here.
All right. But the house itself, the living area, will be
The main floor will be up
here.
This is 9-foot ceilings. 10'3" from here is the elevation of the main floor, which is going to have it's a 3-bedroom,
big laundry room,
3-bath, big kitchen,
yeah.
huge great room, vaulted ceilings.
Will it be just above this, or is it going to extend that way?
It goes above this and extends over that way. This is the midpoint. This is the midpoint of the entire structure. So the house will go that far that direction. So this is the center of the house right here.
Right.
So the garage and the shop are over there. Bedroom, entryway, great room.
It'll be a modern farmhouse.
Yeah, it's going to be modern farmhouse style.
Somebody just says, I thought new houses could not have fireplaces in Santa Rosa.
Well, these are
They're
gas
electric.
fireplaces.
These are gas?
This isn't wood.
This isn't a wood burning. Yeah, no wood burning.
Yeah.
All right, so we have Nicholas over here. He's going to talk a little bit about the system itself. Because these are forms. These are actual forms where concrete is going to be poured in.
Yep.
So Nicholas, maybe you can tell us who you are first.
Yeah, I'm Nicky Fork. I'm the head trainer for North America for the IntegraSpec ICF system. And our system is a forming system, so we have a forming panel that gets assembled with web spacers. We do the footings, we do the walls, we do the roof, with the entire retaining walls with this type of system. This is a stay-in-place form that gives you the insulation, vapor
So this
barrier.
doesn't go away.
This stays in place forever. So it's your insulation, vapor barrier, air barrier, and studs all in one assembly. We have a plastic girder truss stud that's embedded into our forms everywhere you see the name of the company. And this is 8 inches on center, which allows you to fasten any kind of finish you want to this, or hang cabinets.
You can stucco on the exterior.
Stucco gets applied to the actual form itself without any other requirements for building paper or chicken wire. The actual acrylic stuccos will embed and bond to the actual material.
Can we go over here to a wall where you were explaining how the concrete gets poured?
Yes. So here we have a window opening, which gives you visibility to the inside of the
This
system.
is a window. Okay.
This is an actual window that will go right up to the ceiling. So our wall system gets erected. Inside of the cavity, what you have is a web spacer. So in this case, he's got an 8-inch core. This is to comply with the 2020 12-inch wall. We're actually 13 inches over here. So inside of here now is where the concrete will be placed. And you have horizontal rebar and vertical rebar that occur inside of here. And that acts as a skeleton tendon to hold the structure together for seismic. So it gives you this concrete reinforcement. So concrete gets poured with a pump truck down into these walls, gets totally filled, and we will be pouring these walls and the floor for this part of the building all in one time.
You were saying that the thermodynamically, the temperature of the walls will stay the same as the temperature of the ground?
Yeah, what we have here is a wicking effect. Concrete and steel are conductors, and if you put your hand in there, you can feel the cold temperature of the steel that's inside of here. So the ground itself, if we go to a cave, anywhere where there's a cave, there's been houses that have been burned. This thermal shell is a thermal highway in here for the ground source temperature to be wicked up into the building. So the wide footings actually take that ground source temperature, transfer it to the walls. Now this entire shell is going to be surrounded by the ground source temperature. So it's the same equivalency of having take a wood house if you want and cover it in 24 feet of soil. That's the berming effect that this system causes. So having the insulation here in place and the thermal mass here, we all know that you walk on concrete in this or travertine or whatever in this hot sun, it's hot.
Okay,
At nighttime it's cold.
I'm gonna just remind a few people. I'm up here in Fountaingrove in Santa Rosa. One of the viewers asked whether or not you would be doing sheetrock here, but
well, you have the option of sheetrock. Our preference right now, what we've found from sheetrock, the skin of the sheetrock is paper, and it will burn. It will also support mold. So if it gets wet in a damp area, it supports mold. So we decided, let's turn this into a totally green package and shell. So we go to Den's glass on the actual inside, which is a fiberglass product, 4x8 sheet, still performs and gets installed the same way as sheetrock, but it's a much better product. Also, there's a plaster that can go on the inside, so you can skip all that too if you want, and go to this plaster finish that is like a Venetian plaster. So it comes down to aesthetics. If you want that look, you have that versatility. But right now, anywhere we would normally put drywall, we use the dense glass for the fireproof aspect and for the mold and mildew aspect as well.
Okay. Another question somebody asked is, I guess maybe this is somebody who's rebuilding their home, but they're wondering what the per square foot cost is versus a wood frame home.
Yeah, I think that's case by case comparison. When we talk about the degree of difficulty and the complexity of the home dictates what the square foot cost can be. Our shells, if we just talk about the shell, because the finishes, regardless whether it's wood or this, are going to be the same. So if you're buying doors or windows, it's the same price as, if you're putting down tile, it's the same price. So if we talk about just the shell, which is the frame that we looking at here, we could be anywhere from $55 to $70 for the shell. As a framing package, and again, it's relative, because what happens with square foot cost is somebody has a house where the walls are 8 feet. We just did a house over in St. Helena, and they had 26-foot tall great room, grand foyer area. So that cost per square foot is going to be different than this. And so the smallest one, say at 8 feet, could be 55. The taller ones are 70.
Okay, so 55 versus a wood frame.
Wood frame, when I was talking to some of the track builders, they're talking $70 to $85.
So it's comparable?
Yeah. So we're in a lot of cases we were cheaper, And again, I think it's relative to the builder. And if we're talking 2x4 versus 2x6, or if we're talking 2020 double stud 2x6 with blown in foam, we're much cheaper. We're probably
so up here on Fountaingrove, how many homes are you guys doing?
Right now we've got 20 in contract. And,
here in Fountaingrove?
Yeah. And
wow.
Then I think we're in negotiation and estimating for about 100 of them right now. So.
And do you find with a lot of these homeowners that desire just to be safe, to not have their, to not be in the same situation they were last year?
No, well, see, what I've done is a lot of presentations to homeowner associations where they have, they bring in committees and the heads of the homeowner association plus a lot of the residents. And I've been in 3 fires myself. I got pulled out of 1, so I understand that emotional effect, And the people, I think the heartbreaking part for them was they were almost to the point where they were just going to give up and move out.
Yeah.
To have to start all over again, and especially if they thought they had to build with wood again, that fear of this happening again was fresh. The smell of ashes is fresh. What I did find is when I talked to them and reassured them that this is totally non-combustible, it's code-proof and non-combustible, it gave them a sense of feeling of hope, like even though they lost their memorabilia and artifacts that were important to them, they know that they won't lose them again. That this structure, you could bunker down during a firestorm and survive. If you had to leave, that everything in your building is going to be, survive. Even your animals are going to be safe. So that gave them a whole new hope, and they said they would only stay here if they could have a fireproof structure. And their options were minimal, limited, because any one of the other sub-builders coming in, talking to them and giving them presentations, and I was there several times because we were doing presentations after them. Well, number one question is, what's going to happen in another fire? Well, the answers they got from the other industries were, well, just make sure you got good fire insurance, because they said yes, it's going to burn again, but I'm saying no, it's not. And people say, well, how can you say that if how do you know it's going to? Because this fire was extremely hot. I went after the fire. I came here with a drone and I drove around. I took a lot of pictures. The only thing standing is concrete. Fireplaces are still there. Foundations are still there. Concrete doesn't burn. If I'm going to build a fireplace for wood, I build it out of concrete. So that's what we use to burn wood. So these shells are 100% concrete. So they don't support combustion. I've been in 2 scenarios already with our building materials in fires, and we don't burn. It's a firewall. We're putting perimeter fences around these properties out of our material, so we're having concrete fences that go
Is that
around.
right?
Yeah. So those act as firewalls and fire barriers. So the ground source fire that usually initiates the coming to the building will be stopped. The fire can't get past that.
No wood.
No, there's nothing to consume. And again, that testimonial. You go around, the old foundations are still standing, the chimneys are still standing. There was areas where I looked where there was 3/4 inch of stucco skin that was standing by itself. The support structure that used to be there was gone, but the stucco skin made out of Portland cement is still standing there, hanging on like a sail. So it did not burn. It does not support combustion.
I was talking to a woman whose house didn't burn. She had a concrete roof,
Okay.
relatively new, but everything around her burned.
So she had a concrete tile roof
Yeah.
that went on. So what that did is it took the brunt of the heat and deflected the heat so that it didn't allow the structure below to ignite. And because a lot of these homes, because of the soft venting, the torch from the roof, because the venturi that creates that wind blowing sucked in, like bellows, it fanned the fuel for the actual fire. It got into the combustible component and then lit up. But if you didn't have anything that allowed that fire to initiate, then the fires basically run through in 20 minutes. If there's nothing to consume, the fire's not going to stay there.
Was it the homes that caused or that propagated the fire, or was it the trees up here?
Well, no. Well, see, the tree fires are usually about 1,200 degrees
Okay.
Fahrenheit, and that's a normal burn. The homes, it doubled that because the building materials, when you have OSBs and plywoods and all these different types of glues and laminates and things, it's density that's more dense than what the actual natural force would have. But then those chemicals are ignited as well, and that's what created the extra heat, or doubled the heat basically. And of course the high winds made it even worse. But that accelerated the fire even more.
Wow.
So if that area was trees only, it would have been different. It wouldn't have reached those temperatures, and it obviously the trees would still, but you wouldn't have had that disaster impact. Now, if all of those homes were concrete, we wouldn't be having this conversation because they would still be there. The foliage would be gone, but not the houses. There's no way.
All right. Well, thank you.
Yeah, thank you.
Again, it was Nicholas.
Nicholas Nikifor.
And the company is called
IntegraSpec ICF.
And where is it based?
The head company, head office is in Canada, and they have 8 manufacturing facilities across the United States.
They have how many?
8.
8?
And then there's one in California in the Bakersfield area.
In the Bakersfield. And you are based out of where?
I'm based out of the El Dorado Hills, Sacramento area.
Okay. And how many of these have you built?
I've been building these for 20 years, thousands. Yeah.
20
years.
I was going to say, why now? I mean, why don't we see more of these in the residential
Well, I
sector?
think there is more than you know, because as John had stated earlier, is that you don't, once it's built, you don't know any different, right? And I think what we're looking at right now is like we're starting off. Like I'm active worldwide. We're building worldwide. So on the East Coast, you had Matthew, the hurricane, then you had Irma, then you had your tornadoes, and then you had your floods, and then California lit up with the fire. So California was the last frontier for our system to be brought to, because manufacturing started on the East Coast and eventually moved Midwest. So if we were shipping from the East Coast to here, it would be cost effective,
I see.
And so in the last 10 years, we've been manufacturing in this area. And it's bringing this to the table, making people aware, and doing shows, and we're very, very busy, and we're growing rapidly, but it doesn't have the Oprah effect yet until we have a situation like this where people are sourcing and seeking an alternative, or requesting an opportunity to have something more sustainable. Now, when we look at California in retrospect, now that it's actually adapted this type of technology and is sourcing it, I've met with the state-of-the architect, and I've met with the Cal Energy Commission. They came to my house, which is on my business card, and asked if it was possible to do net zero, and I proved to them that it could be done. and next thing the codes are changed so that California is the first state, even though it's the last one to embrace the technology, it's the first state to mandate net zero. So the next one is New York, and then it's going to backwash. So California is going to lead the campaign for the better sustainable way. It needed to set the benchmark higher so that everybody now is going to you know, try to improve, and because of that you're going to see a lot more of this technology. We're talking about California being probably in the worst disaster potential of most states, even though the hurricanes are you know, frequent and the tornadoes are frequent. Look at how many fires are going on every year in California. I mean, the last count was 22. Before that, there was 32. A lot of them active and still, you know, red. I mean, after Santa Rosa lit up, and then the Thomas fire lit up, and then you got Redding fire. So it just seems to compound. Zach's another homeowner you could talk to as well in a minute.
Exactly.
But so when you look at the potential of disaster, this is the second time for Santa Rosa. I've already done houses in Santa Cruz and Santa Barbara and down in Poway and San Diego on those fire rebuilds, you know.
Is that right?
Yeah, so a lot of those people are coming back. A lot of people deserted and selling their lots because they just the memories and thoughts of what they went through, they don't want to bear that again. But I think this is a new hope for people, because it's like, I can now do this once and it'll be here for the rest of my life or my children's life, you know.
What you're describing is a bunker, like a disaster bunker that looks like a house.
It is, you know, it's a shelter. Like I've designed and built a lot of churches that are used as refuge centers and shelters in disaster conditions, you know. So for instance, with FEMA, there's designs I did back east where, you know, in Kansas, I was there with Discovery Channel with Greensburg, where they rebuilt that town after an F5 tornado, and they wanted it to be sustainable. So we will sustain an F5 tornado, we will sustain a hurricane. We've done it already. We have a complex in Orange Beach, Alabama that was 160,000 square foot building that went through Katrina and Irma. It was the only building standing. So it took those 3 hurricanes. So that, you know, when we have an earthquake here, one of the elements that happens with the earthquake is fire, because you end up with the building and the structures and the gas lines damaging, and then so if the earthquake didn't get you, the fire will.
Well, that's what got San Francisco.
Exactly. So this will prevent that, because it'll take the earthquake. It's a monolithic structure that's all tied together with rebar, vertical, horizontal.
What do you mean monolithic structure?
Well, what we have in conventional construction, and I'll just blanket that as a common term, is independent pieces put together that create hinge points. So like if you have a stud system, you have 3 nails on top and 3 on the bottom, and you have independent points of potential hinging. The floor system's the same thing. Whereas where I described to you, we're going to pour these walls and the floor at the same time. Now we've just cast in place a big rock.
Okay.
You know, there's no hinge points.
A hollowed out.
Yeah. If we took a big granite rock and went in with the grinders and hollowed it all out to give you this cavity, we're creating that cavity as a cast-in place pour. So the monolithic pour means you pour once with no hinge points. You know, everything is all one piece and connected. So that's a huge advantage in terms of time, in terms of efficiency of the building, in terms of wind loads, in terms of earthquake with the potential rocking. There's no diaphragm. You know, in a hinge point system, you have a diaphragm that does this. Our system, the whole building, if it needed to, would move as one.
Okay. All right, Nicholas, thank you so much.
Thank you so much. And Zach is a homeowner. He's going to be doing several homes as well. He lost his home, and he came here to get familiar with the training of this.
Oh, I see.
And you could ask him why he's a builder as well.
Oh, he's a builder as well.
Yeah.
All right, so this is Martin Espinoza. I'm gonna do some interviews here, but I just wanted to let you guys know I'm up here on Fountaingrove, the Santa Rosa's Fountaingrove neighborhood. Here we can get across. We can see that's Quayside over there. That's Verena, and the shopping center Fountaingrove that got burned down. So I'm on Palazzo Court, and I'll get another view here of this. It does kind of look like a Lego building. All these pieces are put together. Here, you can see. and then the concrete gets poured. All right. You do see homes up here that are being built, wood frame homes. Not too many homes out here in Fountaingrove yet. Some down there.